Graphing using polar coordinates. Okay, now polar coordinates is really the set of all the points r theta such that r equals f of theta. So if we're trying to sketch it, we substitute the theta in where it says in the equation and we'll work out the r, and then it's going to be the even points spread out from x and y. So example 26, sketch the spiral with polar equation r equals theta for theta between 0 and 2 pi. So if theta equals 0, we get r equals 0. Theta equals pi on 2. I'm only going to do the main ones. Then r equals pi on 2. Theta equals pi. We get r equals pi. Theta equals 3 pi on 2. Gives us r equals 3 pi on 2. And theta equals 2 pi gives us r equals 2 pi. So on the sketch, it'll help if I can do this evenly. So we've got 0, 0. So we're going to put it right there. Pi on 2 and pi on 2. Then pi, I'm going to double that. There's there. Pi on 2, pi, 3 pi on 2. And pi on 2, 3, 4. That is 2 pi there. So on the sketch, I've got the dot there. Then when it's pi on 2, when it's pi, so it gets bigger and bigger and bigger as it's spiraling out. So I've got like this, and then it's going to come circular like this, getting bigger. It's supposed to be more of a circular thing, and like that, and it's going to stop there. So I've got to put my axis on there. That's that one. Circle. Now circle is going to have concentric ones coming out. A circle of radius a centered at the origin has polar coordinates r equals a. So very important. For circles not centered at the origin, the polar equations are less obvious, so we can't really say that one. So example 27 says the curve has polar equation r equals 2 sine theta. Show that its Cartesian equation is that. Okay, so we're going to remember a couple of things here. So remember that we have x squared plus y squared equals r squared is the equation of the circle. We also know that r equals 2 sine theta. And if I times everything by r, so I can get this r squared, I get r squared equals 2 r sine theta. But also from trig, we should remember that y equals r sine theta. This is from trig. Because remember, if we've got a unit circle and we're working out that part there, the y part is r sine theta. Okay, so therefore we get r squared equals 2y, because r sine theta equals y. So our equation becomes, instead of x squared plus y squared equals r squared, we've got 2y. And therefore we get x squared plus y squared minus 2y equals 0. X squared plus, I'm going to factorise this, y squared minus 2y, this will be plus 1 minus 1 equals 0. And I get x squared plus y minus 1 all squared equals to 1. So I've shown that that's the Cartesian equation for it. Straight lines. Okay. Now, there's the angle theta. Now we should remember straight line through the origin. Angle is fixed. Distance r varies because we're allowed to have negative values of r. Straight line goes in both directions. Straight line that does not go through the origin, then it's a little bit more complicated. Then we have this form of the Cartesian equation and we get converted to this form of the polar form. Example 28. Express x plus y equal to 1 in polar form. So just remember that the first thing, x equals r cos theta and y equals r sine theta. Okay, therefore x plus y equals to 1 becomes r cos theta plus r sine theta equals 1. Take out r cos theta plus sine theta equals 1. And therefore r equals 1 divided by cos theta plus sine theta is the polar form. For part B, part A there, part B here, express that in Cartesian form. So let me just write it. R equals 2 divided by 3 cos theta minus 4 sine theta. I'm going to add to this in a minute. Now just remember that we've got cos theta equals, rearranging this one here, and then I'll arrange that one there. Cos theta equals x over r, and sine theta equals y over r. So substituting those in here, I get r equals 2 divided by 3 x over r minus 4 y over r, which means I get 3x minus 4y over r, and therefore r equals 2r divided by 3x minus 4y. Now r being the unit circle, which is 1, I end up getting 1 equals 2 divided by 3x minus 4y, and therefore 3x minus 4y equals 2 is the Cartesian form.